If you work in the information technology field, you're probably already aware that one of the most effective ways to sharpen your skills in any specific discipline, whether it be system administration, networking, security, or any other number of possible areas, is to build a home lab. Many of you watching this likely already have such a setup, but for those of you who don't, or for those looking to expand upon your current configuration, this episode's for you. In my former life, I was a network engineer, so my first lab consisted of an OpenVZ containerization server running on HP microserver hardware, as you see in the left picture, as well as a rack of Cisco routing and switching gear that I picked up off eBay, as you see in the right picture. This was invaluable to me as I was studying for my CCNA and later CCNP. But as I transitioned to security, I ended up rebuilding the entire lab to reflect an environment that was more conducive to that discipline. In this video, we're going to take a brief look at my current setup, both the hardware and the software running on that hardware. We'll take a look at things such as Splunk and LogRhythm's NetMon Freemium, as well as a few other things that I use to create 13 Cubed episodes, test theories, perform research, and practice my skills. I think many of you will find the information useful, so let's get started. First, let's take a look at the gear that I use to create 13 Cubed episodes and interact with the lab equipment. This is an iMac 27 mid-2017 with an i7-7700K CPU, 64 gigs of DDR4 RAM, a Radeon Pro 580 8GB GPU, and SSD storage. And to the right of that is an LG 27UK850W USB-C display. To the right of the computer desk is a separate stand containing all of the network gear, as well as the ESXi Server. Starting on the top left, we have an APC Back-UPS Pro 1500S UPS, an Arris SURFboard SB6190 cable modem, and then the first of the Ubiquiti gear that you'll see. This is a CloudKey Gen 2 Plus, which provides UniFi software-defined networking and UniFi Protect network video storage. Above that is a Gigabit Ethernet tap from SharkTap, and then we see another stack of Ubiquiti gear, starting on the top with the black EdgeRouter PoE 5, and then two UniFi switches. These are US8 150Ws. As we pan down, you'll notice a Shuttle barebones. This is an SZ170R8 V2, and inside of it I placed an i7-7700 non-K CPU, just because it has lower TDP, 64 gigs of RAM, and SSD storage. This is currently running the free version of ESXi 6.7. I'll leave a link to all of this hardware, as well as the software that we'll take a look at in the next section, in the video's description. So now let's dive into the actual software running on all of this hardware. Alright, first off, let's take a look at the Ubiquiti hardware I have running in the lab. This is the management portal for the UniFi CloudKey Gen 2 Plus. This device, as previously mentioned, hosts UniFi software-defined networking and UniFi Protect, which is the successor to UniFi Video. This is the camera management system and network video recorder. This device ships with a Qualcomm 64-bit 8-core CPU, 3 gigs of RAM, a 1TB 2.5-inch SATA drive that I have since upgraded to 2 terabytes, and you can upgrade it all the way up to 5 terabytes currently, 32 gigs of eMMC storage that's built in, and I have added, via the slot in the back, a 32 gig micro SD card for configuration backups, which is a bit overkill. So that's the overview tab. We have performance, which shows performance. Basic stats for the CPU, memory, and storage. Under controllers, we see information pertaining to the two controllers running on this device. Under network, we of course have network configuration related information and data transferred. And under settings, we have the device name, time zone, and other information. So that's the management portal for the CloudKey Gen 2 Plus. Prior to this, I actually ran two separate VMs within the ESXi box that we'll take a look at next. And those two VMs provided UniFi SDN and UniFi Video, which again was the predecessor to UniFi Protect. But I find this device to be more convenient because it's one physical small piece of hardware, it's powered via PoE, and it's just an awesome device. I've been very, very pleased with it. Here is UniFi SDN, which is running from the device. This is the main overview page. You'll note that it says I do not have a UniFi security gateway connected. That's because I'm using an edge router, as I previously mentioned, and we'll take a look at that in just a moment. You'll note that I have two switches, one access point, 24 clients currently connected, and so on. Under statistics, we find statistics. Pretty self-explanatory, but you can drill down into a lot of information here. The map will actually show all of the different devices connected to the network. The topology is what it's currently set to. The Devices tab shows devices. Of course, there's one AP and two switches, as I previously mentioned, and here you can see the models, versions, and uptimes. Under clients, we see all of the currently connected wired and wireless clients, along with numerous information available for each, which is really awesome. And then Insights will show historical data. You can determine the time period in which you wish to keep that data. I think I have 90 days, for example, set. Next, we have UniFi Protect, which again is running on the same device. You'll note the three cameras that are currently connected, along with some basic information. And I'm not going to click on it, but on the left side is where we can find live views of the cameras, and we can scrub back through historical events or even do time lapse, which is pretty cool. Next up, we have the Edge Router. This is not part of the UniFi family, this is part of the EdgeOS family, so it doesn't really fit into that ecosystem, even though it is a Ubiquiti device. This is a more than capable router. Across the top, you'll notice configuration for traffic analysis, routing, firewall and NAT services, so on and so forth. This device can do a lot. Now, at some point, if they do upgrade the UniFi security gateway to a second version that's a little bit more powerful and capable, I might consider upgrading to it. But for now, this device does a wonderful job. And again, it's the PoE 5. I'm not actually using any PoE functionality, but I used to when I first got it. At this point, it just serves as a router for two different networks, a trusted network and an untrusted network. And that's pretty much it. So in the next section of the video, we're going to take a look at the ESXi server, along with the virtual machines that I have running on it, to include Splunk and LogRhythm's NetMon Freemium. So let's take a look at that next. This is the ESXi server, and you'll note the hardware specifications that I mentioned earlier, including the make and model of the chassis, CPU, memory, networking, and storage related information. We also see a performance summary for the last hour in this section, system information, and configuration information. In the top left, we see the version of ESXi running, the state, and the uptime. We also have some tools to be able to create VMs, shut down, reboot, refresh, and we can also enter maintenance mode from this area, lockdown mode, etc. We see the current CPU memory and storage utilization listed here, and across the bottom we see any recent tasks. Let's go ahead and click on virtual machines, of which there are currently 7 on this host, and I'll sort them by name and resize this to fit. Starting at the top, we have a machine called Eden. This is a CentOS 7 64-bit VM with 2 virtual CPUs and 8 gigs of RAM, and this runs Splunk. In case you're not aware, Splunk offers a free license that's limited to 500 megs of indexing per day, and it also disables authentication, so it's really just meant for a lab or demo environment, but it works great for this. And with these specs, I have no problem indexing data. Next, I have 2 name servers, NS and NS2, that are in a master-slave configuration running bind. I do this to serve the 13cubed.local domain. So all of my lab gear has name.13cubed.local in DNS and also has reverse DNS configured. These boxes also pull down a weekly feed of domains associated with ad networks and malware, and then those are basically resolved to 127.0.0.1 to make sure that they don't go anywhere. Prior to this, I did use a Pi-hole on a Raspberry Pi, and that worked great, but I just wanted something a little bit more flexible, so I decided to roll my own DNS with bind, and that's why I built these two machines in the master-slave configuration that I have. Next up, we have Rigel. This is the only current Ubuntu box, and it's 1604 LTS 64-bit with the same specs as the name server, which would be 1 virtual CPU and 2 gigs of RAM. This device runs TCP dump and captures 30 days worth of PCAP for TCP and UDP 53, so in other words, DNS. I take that data and send it over to Splunk, where I have a custom dashboard that shows me in a pie chart the most frequently resolved host names in the environment. So that happens on an hourly basis, and it's just kind of neat to see that data. Plus, if I ever need to, I can go back and look at 30 days worth of that PCAP. Titus is a virtual appliance that is CentOS 7 64-bit. It's the most powerful virtual machine in that it has 4 vCPUs assigned and 16 gigs of memory. This is LogRhythm's NetMon Freemium, and we'll actually see that in just a bit. And then at the bottom, I have 2 machines that are currently off. This is a Server 2012 R2, and this is a Server 2016 VM. I power them on every once in a while to update them, and I use them also for creation of 13 Cubed episodes, which several of the episodes you've likely seen had these boxes as part of that demo and lab setup. On the left, we can click on storage, and I currently just have a single 480 gig SSD. I believe it's a SanDisk SSD, but this is just fine for the lab environment. I have plenty of physical room to add additional storage, but this single data store is listed here, which I've simply called Data Store 1. You'll note that it is listed as SSD, and it's running VMFS 6, which is the newest file system from VMware. If I click on this, I'll actually get some detailed information about that data store. And you can see that it's a SanDisk Ultra 2 480 gig. If I click on Monitor, I can see any recent events associated with this data store. And then lastly, on the left side, networking. For my port groups, I have the management network, which is what we're using to actually see this web GUI. This is the actual management for the ESXi server. And then I have a trusted and untrusted VM network, and then SPAN targets. SPAN, of course, is a Cisco term, but it means switch port analyzer. This is where the mirrored traffic from that SharkTap that I showed you previously goes. If I click on virtual switches, you note that I have 3, and then the actual physical NICs, I have 4, 3 of which I'm currently using. One of the NICs is used for the management network, one of the NICs is used for the VM network, and then the last NIC is used for the recipient of all of that SPAN traffic. So basically all of the data coming from that SharkTap is going into its own independent gig interface. And that pretty much wraps up the ESXi configuration. So what we're going to do in the next 2 sections is look at Splunk and then look at LogRhythm's NetMon Freemium. So let's take a look at that next. And this is Splunk. Nothing too exciting here. We're just looking at the searching and reporting app and the main search blank here that you see at the top. I can enter any free-form data here, or I can use Splunk search syntax to create very complex queries and visualizations, graphs, charts, all kinds of things like that. If I look at search history, you'll see some of that. For example, here I'm searching for a specific host, a specific string associated with the host, looking at the first 10 returned lines, and then specifying a search time. But here I'm just searching for free-form text of WP_admin, which would search across all indexed data to include the Apache weblogs where I might see something relating to this. And here I'm searching for the value of an indexed field. The field name is wireless_MAC, and here you can see the value. There can be an entire series of videos in and of themselves covering Splunk search syntax, and that's way beyond the scope of what I want to get into here. Under what to search, you'll notice I've indexed about 600,000 events, the earliest of which is 7 days ago, the latest of which was just a few seconds ago. This is live as we're looking at this. So I'm going to click on Data Summary, and under Hosts, you will actually see many of the different hosts that you saw within the ESXi environment. They are actually sending log data into Splunk, as are the Ubiquiti devices that we talked about earlier, such as PoE. And you'll notice the 13cubed.local domain all the way down except for this guy. This is the production web server hosted at AWS, which is sending live log data into Splunk here. So these are all of the hosts from which I can expect data into Splunk. If I click on Sources, you'll actually see the full log paths for the logs that are being pulled in. Varlog offlog, and of course the counterpart on a Red Hat box, Varlog secure. We see Varlog messages, of course. We see web logs associated with 13cubed.com, software installations here, and various other types of data. At the very bottom, you see UDP 49514, which is in the private port range. This is where I'm sending syslog data into Splunk. I'm using that particular port, so the data that's coming in from some of the Ubiquiti devices is coming into UDP 49514. And using reverse DNS, Splunk is smart enough to be able to determine the actual name. So under hosts, that's how it knows that, for example, a particular IP address is actually PoE, or another one is actually Unify-AP1. It's using reverse DNS for that, because all of this Ubiquiti data is coming in via syslog, whereas this data is coming in from Splunk Universal Forwarders. So under source types, I basically have defined two different ones. Linux, because all of the boxes I have that are sending data in are Linux, and then syslog. And that's pretty much it for the data summary. Now I will show you a custom dashboard I built called Home, and unfortunately I'll have to redact some of this data. Under top VPN connections, I can see any VPNs into the house. So in other words, if someone is using remote access VPN, that's going to show up here. So if I'm traveling and I VPN back to my house, or if I'm at work and I VPN back home, a pie graph will be generated here showing those IP addresses within the last 24 hours. But I've had to clear that for obvious reasons. And then you see the top DNS queries, which unfortunately I've had to blur out. But this is the data that's being provided by that Rigel VM that I explained earlier, which is using TCP dump to grab TCP UDP port 53 traffic. So I can see my top DNS queries throughout the last hour. On the top right, we see top Sorona visitors. And again, I have to redact this, but this is basically IP addresses associated with 13cube.com, so people visiting the website. I see my latest DHCP leases here, so the various devices throughout the house and the time at which they obtained a DHCP lease. So I have time, hostname, MAC address, and the actual address that was leased. I also see my latest wireless associations, where I have a time and a MAC address of what was associated. So for example, this is F86F and it ends at E0B6, which matches this. So this happens to be the Apple Watch, which last associated in this date and timestamp. And then if I scroll down towards the bottom, it's showing me anything with the word error in it. So basically any kind of error-related activity. These happen to be associated with DNS. So this, again, is a custom dashboard that I built, and the sky is truly the limit. I can build endless numbers of visualizations here and pretty much do anything I want. I can also build, custom data sets here, custom reports. Here's the alerts section, but unfortunately, this feature is not available, as you can see here, with the free version of Splunk. I really wish this functionality was available. And then under dashboards, this is where I built the custom home dashboard. Across the top, we see messages, of which there are none, but if there's like a version update or something like that, it would appear here. Here's settings. Again, pretty self-explanatory stuff here. This is where you configure Splunk. If I go to monitoring console, I can actually see some specs showing the indexing rate. Here I see the specs associated with the VM, the version of Splunk, which is the newest as of the recording of this episode, and various other things associated with that. So that, in a nutshell, is Splunk. Next and lastly, we're going to take a look at LogRhythm NetMon Freemium. This is LogRhythm Network Monitor Freemium, and as the name implies, this is a free product. Though with a simple license application, you can turn it into the full commercial product. It's really the same software. It's only the license that determines the difference in functionality. This is perfect for a lab environment, and I've been running it for a couple of months now. If you've used other Elk Stack related products, then this will be familiar to you. But you're looking at one of the pre-built dashboards that comes with NetMon. This is called the Analyze dashboard, and is showing us the last 15 minutes worth of top applications by bandwidth, which in this case is pretty sad because all it's showing us is Apple and another little section of Apple here. That's because there's not a whole lot going on right now, but you get the idea. On the right side, you'll see a legend with additional data that has been classified at some point, things like SSL, Outlook, DNS, iCloud, HTTPS, and so on and so forth. You'll also see a pie graph also showing top applications by bandwidth, and another pie graph showing top applications by packet count. Along the bottom, we have the Analyze table where all the details live. Apologies for having to redact some of this data. The network tap that I showed you earlier is positioned in between the cable modem and the router. So in other words, the handoff from the cable modem goes into the tap, and then the tap is sending all of that data into one of the dedicated interfaces on the ESXi box, and then it's passing through to the router. So some of the IP addresses here are actually the WAN IP address. Obviously, I don't want to expose that in the video. But if we look at one of these things, such as the top one here, if I click the arrow and scroll down, you'll see all of the details, such as the application, application ID, path, whether or not it was captured data, because this system does do full packet capture, destination IP, destination MAC, port, duration, just a wealth of data available to us. And it pulls all of this out for each of these identified applications. And this is just one of the many dashboards. Let's go up to the top here and click on another dashboard, such as the Capture dashboard. So this is actually showing us captured data. And you can see quite a bit of information here with regards to the top applications by bandwidth as far as what's been captured. And on the right side, we also see a nice pie graph that shows us additional information. Along the bottom, again, we have all of the detailed data. And if I click this little down arrow right here, we can actually download a zip and have the actual PCAP data, which is really cool. So next, let's go ahead and click on Alarms. This is the Alarms dashboard for the last 15 minutes. And you can see that one alarm is currently active, which is called Flow Proto Mismatch Port. Turns out that some of the Amazon Echo devices I have in the house, for whatever reason, are triggering this alarm, because what it's saying is that there's a protocol mismatch. In other words, let's say it's supposed to be HTTP traffic, but there's a non-HTTP protocol riding on TCP/80, and it's triggering that alarm because of this. Once again, I can drill into this by clicking on the little arrow and getting all of the gory details. So pretty cool here. And of course, I can also change the time to anything I want. Under Rules, we can define custom query rules, and this is where you'll find the deep packet analytics rules as well, including the rule that triggered that alarm I just showed you, which is here. If we go to Replay, we can actually specify a PCAP to replay into LogRhythm to facilitate analysis. Configuration is where the configuration is performed. And if I click on Network, you'll actually see a live view of the interfaces. Again, not a whole lot going on right now, but it shows you the packet and data rates, and it also shows you the interface on which data is captured, which in this case is ENS 224. We also have the management interface configuration, the hostname settings, and so on. And then all of the other data here is pretty self-explanatory. I'll click on Capture, and you can see Capture All, though we can specify certain applications to exclude from the packet capture. And I'll also show you the storage section here, which is where you see /pcap0, which is the mount point where the PCAPs are stored. Currently 87% utilized, but I don't have to manage this. The system will automatically employ a first in, last out kind of rotation for that data. You can see I've given it 30 gigs. Under Diagnostics, we can see packet and data rates. We can also click on Packet Capture here and get anything dealing with failed or successful sessions that are written to disk. And again, this is all live data that it's pulling from it. And then under Logs, we can actually get logs from the engine itself, along with all of these other logs. And just like Splunk, I could make an entire video just about LogRhythm Network Monitor Freemium, and maybe I'll do that if there's enough interest. But the whole purpose of this was to just very quickly show you what it looked like and how it worked. And again, we're back to the alarms dashboard here, but I hope that you will check this out. And again, I'm going to leave a link to all of this hardware and software that I'm using in this episode's description, so be sure and check that out. But that wraps up the home lab that I wanted to show you. And I hope that some of the information I've been able to provide to you has been useful or has given you some ideas for your own home labs. That's everything I wanted to cover, and I would like to thank you for watching, thank you for subscribing, and I will catch you in the next episode.